You absolutely have to know how to solve this problem. It's guaranteed to be on the test. The question gives us a 6 and a 0 and asks us to fill in all the blanks. A lot of students get confused when they see this problem and have no idea where to start. Actually, for questions like this, it's really important to find the breakthrough point. So let's look for the breakthrough point together. It's actually right here, because this is the only part where we have no numbers. Look, 60-something minus a 2-digit number equals 0. Wouldn't you say this digit here must be 6? All right, now that we've figured out one number, where should we look next? Pay attention, everyone. This is a 2-digit number minus a 1-digit number, and the result is a 1-digit number. Think about it. Could the highest digit possibly be 2? Could it be 3? If you take something in the 20s and subtract a 1-digit number, you end up with something in the teens. If you subtract a 1-digit number from something in the 30s, you get something in the 20s. So this digit can only be 1. We've figured out another spot. Let's keep going. Here, it's a 2-digit number minus a 1-digit number, and the result is a 1-digit number. What about the next one? A 2-digit number minus a 1-digit number equals a 1-digit number. Wouldn't you say this digit also has to be 1? Because if it were 2, then subtracting a 1-digit number from something in the 20s would give you something in the teens, right? All right, let's fill in all these positions. So how should I observe the next part? Look, when you subtract a 1-digit number from a teen number and get 1, pay attention, this kind of situation, where a teen minus something equals 1, can only be 10 minus 9 equals 1. None of the other possibilities work. Then, as I keep observing, I notice that this 9 comes from multiplying the divisor by the quotient in this digit place. In other words, the two numbers multiplied together give 9. Which numbers multiply to get 9? We know that 3 times 3 is 9. What else? 1 times 9 is 9. So is the divisor 3, or is it 1, or is it 9? I can't be sure right now. Let's keep looking further. Now let's look at the last part. This number in the 60s, even though I don't know exactly what it is, I know that it's the product of those two numbers, right? Is there a case where 3 times something equals a number in the 60s? It doesn't seem like there is. Is there a case where 1 times a single-digit number equals something in the 60s? No, there isn't. So who could it be? It can only be 9. We know that 7 times 9 is 63, so I filled this in, and now I'm sure about the divisor. Okay, look again. Isn't this position also the result of multiplying those two numbers? It's also a multiplication, right? So who can multiply by 9 to get a single-digit number? Isn't it only 1 times 9 equals 9? So if these are all 9s, then the one above must be 1, right? Up to now, we've filled in most of it. What's left is to work backwards from the end. Look, 6 plus 9 equals 15, and 1 plus 9 equals 10. It's filled in. I know this 5 comes down from above, so this spot is 5. This 3 comes down from above, so this spot is 3. We finished this problem. I suggest you give it a like and save it after watching, and watch it a few more times. Otherwise, if you want to use such a useful method again, you might not be able to find it.